This is Mrs. O'Neill for AP Chemistry, Chapter 10, Section 2, Pressure. In this section, you will understand gas pressure, how it is measured, the units used to express it, as well as consider Earth's atmosphere and the pressure it exerts. Again, pause the video, fill in the blanks, and then play to hear my words. So what is pressure? Pressure really is an equation, force per unit area. So we need to talk about the collisions that are force, and the container has the area. So those are your two parts of the equation. Now, where do those collisions come from? Well, molecules are constantly moving. So those collisions are going to come from those molecules hitting the sides of the container, as well as those molecules hitting each other. So it's for force per unit area. How much collisions, how much force are those molecules putting on each other and putting on the sides of the container? A barometer is just a tool used to measure pressure. So here is an example of atmospheric pressure and the barometer. So this gray stuff that's in here is really mercury, and that's where the unit mm, millimeters of mercury, comes from. So if we have 1 atmospheric pressure, it actually equals 760 millimeters of mercury. So the pressure of the atmosphere at sea level will hold 760 millimeters of mercury. That's what this tube is. It's holding 700 millimeters of mercury when there's 1 atmospheric pressure outside. So they equal each other. That's a conversion, so we can go back and forth between the two, which you should be able to do, because when we get to gas law problems, you'll have to do this quite often, because I'm going to remind you that you always want to be in the atmosphere unit for pressure because of the R, which is a gas constant. So these are all units of pressure, and they all equal each other. So you should be able to go from atmosphere to millimeters mercury, or atmosphere to torrs, or atmosphere to kilopascals. That's what that stands for. So pascals would be just your normal base unit, I like to call it, and kilo would be like a kilogram. So in this case, it's a kilopascal. So I want to remind you that for every 1 kilopascal, there's 1,000 pascals. And there's another unit called the bar, which we don't use very often, but I threw it in here just to make sure you had it as a reference. So here's an example. Can you go from 724 millimeters of mercury to kilopascals? I suggest pausing the video, see if you can do it, and then come back and play if you got the answer right. There you go. Hopefully you got that right. You're using the kilopascals and millimeters of mercury as a conversion. So a manometer is a column of mercury to measure pressure. So there are actually 3 scenarios that could happen with this manometer and how we have to adjust. We have to do a little bit of math to adjust for that pressure. So here is where, if we have a gas container and we fill it up with mercury, the pressure of the atmosphere equals the pressure of the gas. How do we know that? Because the height is equal to each other with this mercury column. Okay, so here's our pressure of the gas. We filled it up, right? We filled that, then we put in a whole bunch of mercury, and if the height is exactly the same, we can say that the pressure coming down, because this is an opening, this is open, but now this is like a closed container, right? The mercury is going to contain all the gas in there, so it cannot escape. So the pressure that's pushing down on this side of the mercury is equal to the gas pushing down on that side of the mercury. Scenario 2, we have the height of the gas is much higher than the pressure of the atmosphere. So again, we're going to fill up the gas container, then we're going to pour in some mercury, so it kind of caps it off. And now the opening up here is going to say, the pressure of the atmosphere is less than the pressure of the gas, or we can say that the pressure of the gas is greater than the pressure of the atmosphere. So in order to calculate the pressure of that gas that's in the container, we got to do a little bit of adjustment. And of course, then the other way around. We're filling up the gas container, putting in some mercury, and now we have that the gas is less pressure than the atmospheric pressure that's pushing on this side of the mercury. So here's your 3 manometers, and what do you think we should do mathematically? Well, the first one's pretty easy. If your height difference is exactly the same, they equal each other. So there's really no mathematics to do. But if your pressure of your gas is greater than the pressure of your atmosphere, Then we need to add the pressure difference. And if the pressure of your gas is less than the pressure of your atmosphere, you're going to subtract. So if you need to, take a pause, think that through, make sure you're understanding that you're adding or subtracting the pressure of the mercury, the pressure of the gas, and which way it goes. See you in class.